Greetings and welcome to Make Programming Fun Again. My name is Karol Moroz, and in this video I'm going to show you how to fetch data from a REST API and cache it in an in-memory data store. The API we are going to be interacting with is called Coin API. I've chosen this particular API because it's easy to register even outside of Europe, and they don't have a KYC process if you only want to fetch coin prices. And regarding the data store, I'm going to give you a bit of suspense. You may have heard of Redis. It's a very popular key-value store, and it keeps all of its data in memory. Then there is a val key. Val key is a fork of Redis. It's blazingly fast. Then there is memcache, and all of these are blazingly fast because they store data in memory. But do you know what else stores all of its data in memory? And it is distributed in a single C file, and it doesn't even have a license because it's in public domain. Yes, it's SQLite in memory mode. So in this video we are going to be storing data in SQLite because it's simple, it's easy to use, and it has a SQL-based API. And if you are new to this project, you can download the code from my two previous videos from this repository, github.com/moroz, my surname, /Kinu no Michi. And this Kinu no Michi, the code name for this project, it is an homage to an early adopter of Bitcoin. Kinu is the Japanese word for silk, and Michi is the Japanese word for road. And I'm talking about a website named after a trade route between Tang Dynasty China and the Middle East. Okay, I'm going to close these websites because we are not going to be using them. And we could probably start by just fetching the rates a single time. In order to do this, we're going to need a Coin API token. And as this website says, you can get a free API key. It does involve giving them your name and a payment method. In my case, I have attached a virtual credit card, but they don't charge you. They will just give you $25 in free credits if you sign up and attach a payment method. And then you need to create an API token. In my case, I have already created a specialized API token for this project, so I'm not going to show this process again in this video. Now, wait. In this project, what do we have? We have I'm going to start in this directory called exp, and yesterday we wrote a handler, we wrote a package to fetch updates to exchange rates over WebSocket. Now, I don't really think WebSockets are going to be essential for our use case, which is just displaying prices of products in Bitcoin. And instead I'm going to implement a lazy evaluated cache. So I'm going to start a new, I'm going to just write a new program from scratch. I'm going to just call it exchange rates rest, and the file is going to be called main.go. So in here I'm going to include package main and write a function main. And we're going to need a Coin API key, and I'm going to use my helper method called mustGetEnv, which basically ensures that a value can be fetched from the process environment variables, and if not, it aborts the program. And I have already set up this API key using drenv. Drenv is a simple program that helps you set environment variables in your local directory using these simple shell scripts. So in my case, I already have all of it set up. And so we have a Coin API key, and then we can try and write we're going to have to write some code. So the API we get in here is formed like this. Function fetch exchange rate. So in our case, we want the base and quote. So base quote, these are strings, and we're going to return an HTTP response, I think, and an error. So let's first start by building the URL. So I'm going to copy this base URL like so, and then we're going to have to specify the base and quote symbols. So the URL is going to be fmt sprintf base URL. Basically the base URL plus the base plus quote, like so. So base URL base quote, and then the method is going to be get. Okay, so they have this example here. The text was pretty small, but basically we need to create a new request. So request error equals HTTP new request, and the method is going to be get. The URL is this, and there is no body. If there was an error while creating this request, which is not very likely, we're going to return nil and error. Then we need to add a request header add. So first an accept header, which basically means we are expecting a response in JSON. Application JSON. Let's start with JSON first. And then we are going to add a header called authorization. Now this is add authorization, and this is going to be the API key. Now this is not exactly what they specified in that example, but I'm not going to use their custom header if they also accept a more standard authorization header. And then we get the response. So we can say HTTP default client do request. And then let's try and fetch this and try and actually make a request like this. So fetch exchange rate, and then the bases are going to be, base is going to be BTC, and we want a quote for euros. If error is not nil, log fatal error. And then since this is an HTTP request, we need to close the body after we use it because it is a reader. So defer response body close, and then body error equals IO read all response body, and then fmt print ln string body, like so. So let's see if this works. cd experimental exchange rates rest, go run. Okay, so we did get a response, and it's in JSON. What do we get if we accept a plain? So there was also an option for text plain. What do we get? Okay, it's basically the same thing. So I'm going to stick with application JSON. I think they also support message pack and text JSON. Like, I don't think it's a very helpful API, but whatever. And then we know that these responses, they actually follow a similar pattern, and it's also very similar to what we saw in the WebSocket API yesterday. So I'm just going to copy some data structures from yesterday. And actually, you know what? We have this. Okay, we have this exchange rate event thing, and I think it has exactly the same structure as the response we're getting from here. So I'm instead going to. Yeah, okay, I'm just going to use this type. It's in package called coin API. So we can define a variable called event coin API exchange rate event, and then JSON new decoder from a response body, and then error equals, JSON new decoder decode into the event, and then it's just going to return an error, and then if there was an error we abort, otherwise we can pretty print the event into the terminal. So event, okay, clear the terminal, go run. Okay, and now we did get an event, and we did get a decimal. I mean, we did get get it properly parsed into the time, and we get the base asset ID, the quote asset ID, and then we got this decimal. And I'm also going to check if we can get like the properly formatted decimals. So 1 Bitcoin equals this much euros, and that's going to be event rate, I think. And let's see if this works. Okay, yeah, this looks like it works. Great. So let's say if I wanted to see how much 100 euros would be, I know that decimal and decimal new from int 100, and I want to divide it by event rate, and then I can say something like 100 euros equals this much BTC. Let's see. Yep, this kind of is what I expected. And then we also want it rounded to the basically we only care about the first 8 digits after the point, because that is the resolution of Bitcoin. The smallest denomination of Bitcoin is Satoshi, which is 10 to the power of -8. So we may want to look at decimal shop string. That would be the documentation for this decimal package. And can we somehow round it, or price converted? Okay, price is equals decimal new from int 100 euros, and then converted equals price div event.rate, like so. And then can you somehow round it, or round bank runs the decimal to places, decimal places. Okay, we want no round up. You know what? Yeah, let's see if this works like if it works like this, the way I expected. We want it rounded to 8 decimal places, and it looks like it may have worked. Great. So now that we know how to fetch exchange rates and how to calculate these values, we can try and start building a data store. And in this case, I'm just going to build it straight in the application. So I'm going to put it in rest.go and in package coin API. And then in the coin API, we also have this WebSocket client. And we don't really have to worry about it too much for now. Okay, type coin API REST client struct. And in here, we're going to take a token, which is a string, and we're going to have a database connection. And this is going to be a pointer to an SQL DB. And I think for now, this is fine. And then we're going to add a constructor, new coin API REST client. It's going to take a token string and return a pointer to the REST client and an error, actually, because our operations may fail. So the database connection is going to be DB open, I think. No, SQL open. And then we need a driver, and I'm going to use this driver. This is a library called modernc.org/SQLite. The reason I'm choosing this particular implementation is that it is basically the whole C library, but transpiled into C. It transpiled from C into Go, so it does not require CGO, it does not require a C compiler, and it's just plain Go under the hood. So you can just import it and use it like the other SQLite driver. And I'm going to install it using go get-u modernc.org/SQLite. And then we need to import it like so. And this is because we want its initialization logic to kick in. And then we can just open a connection in memory mode. So if we write it like this, it's just going to open a new in-memory database. I think. Yeah, it's just going to be in memory. So if there was an error, we return nil and the error, and otherwise we return a REST client, and the token is token, and then the database connection is this connection, and no error. And then in order, okay, and then we're going to have to initialize a database connection. So basically we're going to have to write some SQL, and let's see, const init SQL, something like this, create table exchange rates, and then it's going to be base text quote text, rate is going to be, let's just store it as text as well, because there is not really any other way to store decimals reliably. And then we need the quotes time, and I think we're going to store it as milliseconds, as a Unix timestamp in milliseconds. And the reason I'm going to use milliseconds and not the usual Unix time is because we are going to be dealing with pretty low latencies, and ideally we want to know exactly with like a millisecond precision how old the quote is. So I'm just going to call it inserted. I'm just going to call it updated at, and it's going to be a big int, but in SQLite it doesn't really matter because you know, these values are going to be treated as basically SQLite doesn't really have types. It only stores types as the type. It only stores. It doesn't really enforce types, so it doesn't really matter. And I'm going to maybe I'm also going to call it updated at milliseconds, something like this. And then we're going to need to run this. So connection exec, and then connection exec in its SQL. If error is not nil, return nil and error. And then in order for this program to be compliant with an interface we have implemented, because yesterday we explicitly said that the application's router is going to accept an exchange rate service, and this exchange rate service is this interface. So we need to support our exchange rate service needs to support where was it? It needs to support this method called getLatestRate. So I'm going to implement this method quickly on this REST client, but I'm just going to return a hard-coded value. Also, the API is going to change because we want to make it kind of more flexible, I guess. Decimal new from int, 42. No, okay. Value equals this, and we return a pointer to this value, like so. So now if I remove this WebSocket client and replace it with this REST client, Coin API new Coin API REST client with this Coin API key, and then we also take an error. If there was an error, we log fatal, and then we pass this REST client to the router. So let's see if this way we can actually run the application. Go run dot. Okay, we are listening on port 3000, and we know that we are going to be fetching this. We are going to be fetching this value from this store, from this exchange rate service. So since we returned 42, this is what is going to be displayed on the website. So the next thing we could do, actually I'm going to commit at this point. Stub REST client, like so. And then in this REST client, what else can we do? We know that we have a database, so we can define a. Also, by the way, I'm going to move this interface from here to the actual Coin API package. I'm going to specifically create a new file called types.go, package Coin API, type exchange rate service, and we're going to return as a custom type exchange. We are going to need a base symbol, which is going to be a string, a quote symbol, which is going to be a string, and the rate is going to be a decimal, and then the updated timestamp is going to be time, like so. And then we're going to take a base quote, which are strings. And for now, we're just going to hard code Euro and Bitcoin in places that are actually going to call it. But we maybe if we implement any other currencies in the application, this is going to come in handy. So yes, this is an exchange rate struct, and we are going to return. You know what? We can return a pointer actually to exchange rate and an error, because this may error out. So in this, for now, I'm just going to remove this. We could just remove this WebSocket client because it's not really fully implemented. So yeah, I'm going to remove this one from the application. The other one was an experiment. So let's see, func C. I'm going to implement a method to fetch the actual value stored in the database. So it's going to be a method on the REST client, and it's going to be private, and get cached rate. And this is going to take a base and a quote, which are strings, and it's going to return an exchange rate, and it's going to return an error. So cached error equals C get cached rate with a base and quote. If error is not nil, this probably just means that there is no cached value. Base and quote string is going to return an exchange rate or an error. And then if exchange rate, if the error is nil and errors is error. Yeah, we want to check if this is a no errors, SQL no error, no rows. I think it was like this. It just means okay. I'm going to go, we want to check if this rate is present in a database and if it's not expired. So actually, in order to tell if it's expired, we need to know a max age. And it's going to be an int64. Actually an int, because we are developing on a 64-bit platform, so it's going to always be 64 bits. And yeah, we can specify a max age, which is going to be an int, and then client, I'm going to specify a default client like this. So the client is going to be a Coin API REST client with these values. And if the max age specified is less than or equal to 0, then the client's max age is going to be default max age. And then we return a pointer to this client and no error. Okay, and this const default max age is going to be 16,000 milliseconds or 1 minute. And okay, so now I'm going to check if error is nil and cached updated at Unix milliseconds is you know what, this cached updated at yeah, okay. So we want to know if this updated at is after, and this is going to be time now subtract C max age times time millisecond, like this. So check if the quote is present in the database and if it's newer than max age milliseconds. Okay, so now type int and time duration. Okay, sub, is there a sub? Okay, there is. So why can't I multiply it? Okay, and why can I not multiply? Okay, so now this should return. Okay, subtract. Can I call subtract? What are the methods on it? Can I add or can I? Okay. Duration t minus u. No, this is on. What was the actual method? Okay. I think there was a method. Okay. I think there was a method called since or. Wait, time now. And then it's going to be log. Okay, I'm just going to call add with this. So mismatched types int and time duration. So 10 millisecond. Okay. Yeah, I'm just going to run it to int64. Time duration. Okay. Why cannot I add it? Invalid operations c.max age. Can I do it like this? Okay, I could, but this is. Okay, well, I guess I'm going to have to do it like this. Okay, well. And this is going to be -1 times. Yeah, I'm pretty sure there is a better method. So if this is valid, then we return cached and no error. And then if there is an if the error is not nil, which means there was an error and there is no rate, or in case there was an error is not nil, okay, or cached updated at okay, and I'm just going to define a threshold because we're going to define it twice. So the threshold is time now minus minus this, or we could just define the age. No, this is the threshold because we can compare against this age. So this is the threshold, and we want to know that this is after the threshold. And okay, or cache updated at is before the threshold. Actually, it's not after the threshold. But you know what? It's going to happen in every single circumstance, every other circumstance. So instead we can just say new rate updated error equals C fetch rate base quote, and then if error is not nil, return nil and error, I guess. And yeah, we could probably handle it somehow gracefully. And then error equals we have to somehow save update rate, and it's going to be base. Yeah, we're just going to update the rate with this new quote. I'm just going to call it save updated. But you could actually, okay, I can call it refresh rate, and this is going to handle both. And you can just return it here, like this. So function C coin, yeah. So I'm going to also implement this method called refresh rate. And it's going to be also accept the base and quote price. And it's also going to return an exchange rate and error. So in this get cached rate, we are going to first make a query. So row error equals, or we don't even have to do it. I'm going to define this struct. So rate, it's an exchange rate. And yeah, this is going to handle most of it, but we are also going to have an issue with the timestamp, which is stored as milliseconds. So error equals cdb query row, select everything from exchange rates where base equals this and quote equals this. Also, I just realized we did not specify a primary key in here, so this would not be unique. Primary key base quote, like so. I think this is how it works. And then and then we scan into the exchange rates. Okay, Okay, wait, what were the columns? It was base, quote, okay. So I'm just going to write them, spell them out here. Base, quote, rate, updated at milliseconds. So I'm going to scan into base and into the quote and the rate. And then I'm going to define a separate variable for the timestamp. It's going to be an int64, and I'm going to scan into this value because we don't currently have like a custom type for this Unix millisecond. We could implement it in a different video, but it's, I think, outside of the scope of this one. If error is not nil, we return nil and the error. And otherwise, we can say that the rates updated at is going to be time epoch. Is there like a 0 time? I think we could, wait, is this going to be, I think it's just going to be like this. Okay, what does time.unix accept? I think you can just pass 0 and the timestamp times 10,000, and then it's going to be when it should work. I think we'll just see. Okay, and then if we refresh the rate, okay, then we need to make an actual request, and this is going to be similar to what we did here. Oh, we deleted this exchange rate event, not good. Okay, we fetch exchange rate, it's going to be, we're going to make an error like this, and the base URL is going to be in here, the base URL, and then the coin API, the API token is going to be C token, like this. Yep, so response error is this. If error is not nil, we return nil and error. Otherwise, we defer response body, close, and then we can parse the event from JSON. And we're going to need, I think I can just undo this file lib, no, restore lib coin API ws.go. Okay, so var event is going to be exchange rate event, and then error equals JSON new decoder from response body decode into the event. If error is not nil, return nil and error. And then we want to store this actual we want to store this event. So we can make a request. So so what are we actually returning? Are we returning this is basically an exchange rate event. It has the same fields, so we don't really need it here. Is it not? No, not exactly, okay. But we can move it from here. And what does it, okay. So in REST, error equals yeah, we can also do it with query row. So cdb query row okay, cdb exec, this is going to return a result and error, okay. db exec insert into exchange rates base quote rate and updated at milliseconds, values 1111, and then we can pass the events base, asset ID base, quote, events rate as string, and then the events time as I think there was wait, was there no go doc time Unix milli, okay. Okay, so this may work, and if error is not nil, we return nil and error. Otherwise, we return a new event, which is going to have the base of the event we fetched from the API, the quote of event we fetched from the API, the rate of the event we fetched from the API, and updated at of event time. And actually we could probably like unify these types, because it doesn't really make so much sense, but let's stick with it for now. So now, have we actually done everything? Oh no, we haven't passed these base and quote. Okay. I wonder if this is going to work. Go run. Undefined exchange rate service. So page controller this should be coin API exchange rate service, and this is also an exchange rate service, and then we get the latest rate for BTC and Euro, and this is going to this may return an error. If there was an error, we can say HTTP error W500 and error.string. No, error like this. Okay, the other way around, 500. And otherwise we can pass this to this template. So this is going to be coin API event exchange rate, and this is going to be rate.string. So we can say one current rate base equals this much current rate quote. Otherwise no data available. Does it will it run now? Temple generate. Okay, go run. Undefined exchange rate service in Go router. Coin API exchange rate service. Will it run now? Okay, new coin API REST client. We want default, basically main.go, and I'm going to pass 10,000 milliseconds for now. Okay, and we could probably add some sort of logging. So in the REST client we can say log println fetching rate refreshing rates for this pair. So base and quote, like so. I'll run. Okay, and if I go to this page, we can actually see that we got this refreshed. And if I run it again, we are refreshed. Unique constraint failed. Okay, this means the refreshing failed because we did not specify an on conflict base quote do update set rate equals excluded rate updated at millisecond equals excluded updated at milliseconds again. Okay, so we fetch it now, and we can see that it was refreshed again. But why does it always refresh? We did not. Okay, I want to see the logic we have. So get latest rate. So what is the threshold? You know what we could do is with a debugger. Do I have DLV? Okay, I do. So I'm going to run this in a debugger called delve. I'm going to place a breakpoint in here, and I'm going to run it in the debugger. So we can see what do we have. What do we have in TS? Print TS. It's 0 for some reason. What's in the error? No rows in the results set. Okay, continue. Okay. What's going to happen now? Print TS. Okay. Next. Next. What's in rate? Okay, I think it's not quite what we expected. So what's in a nanosecond? Okay, the data we have is in milliseconds and we are passing microseconds. I think that's the reason. So this should be a million instead. So if my assumption is correct, will it work now? Okay. So we are still refreshing for every request. So what is this value now? Okay, what is TS and what is rate now? Okay, so this is the correct clock time, and so I'm guessing this threshold may not be may not be fully correct. Let's see. How is this threshold calculated? P threshold. Okay. P threshold. So this threshold is specified as this time, which looks correct, and this is not in the past. Okay, what does cached say? P cached. Okay, continue. And now P cached, what does it say? The time seems to be correct, and what is the threshold? So the threshold is 18 seconds and the actual time is 23. So we should not refresh. So why are we refreshing? If error is not nil and cached updated at is after. Okay, I'm going to put another breakpoint in here. Okay, so what is cached? And nothing. Okay, continue. What is cached? What is threshold? Okay, the cached is okay, 37. Okay. You know what, I think I just need to specify like a lower threshold or something. Yeah, I'm just going to specify something like 60 seconds and we can see if... Okay. PKL DLV, can we do it? Shit, and I think I have a zombie process now. PKL 10814. Shit. Okay. Great, so we are refreshing rates now. And we are still refreshing rates again. So definitely something is wrong in the logic that checks for the threshold. So I'm just going to do the lazy debugging, log print and error cached threshold cached updated at cached updated at is after the threshold. Okay, let's see. If cached is not nil, log println cached updated at and cached updated at after threshold. Because, okay, go run. Okay, no rows in results set. And then again. So the threshold is okay, so why is this threshold so far so short? Are we doing something stupid again? Okay, we are What is our Cmax age? So max age is 0 for some reason. But why? Okay, max age is max age like so. Okay, so go run. So now we can see that with the initializer correctly set up, we are not refreshing every time we visit the website, which means we are correctly caching. And now I can remove these debug statements like so and rerun it. So now we can see that we are refreshing these rates now, but when I request this website again, we are not refreshing it again. And this means that the caching works. And also I wonder if this is actually, like the valid exchange rate. I think it was similar to what we're getting in the API yesterday. Okay, and so I'm going to commit for now. Get rest plus in memory cache to work. And we are, why do I have this? Okay. So I noticed that we had two types which were basically the same, but the only thing that was different was that they were one was coming from the API and another one was coming from our own application. So I think one thing we could do about it is we could just make this exchange rate event private, so we don't expose it otherwise. And RG exchange rate event. Okay, so we can see that all of Coin API exchange rate event. So we cannot really make it private. We can't make it private because then the REST API would break, but we can make a copy of this type in this file. And then this would just use our local type. And then this could also be local. So we can then indicate that exchange rate event is the type of events sent by Coin API. Exchange rate is for internal use in the application. And then we can define something like JSON base and JSON quote, and then JSON rate, and then JSON updated at. And let's see if this still works. Okay, Coin API ws.go. So exchange. So now we can. Okay. This. Okay. And then in REST, we have this exchange rate event. Like so. Okay, so it seems like this is still going to work. Great. So I think I'm going to wrap up for today. If you enjoy watching me hack projects like this, please consider liking and subscribing. And just as a reminder, my name is Karol Moroz. I am based in Taiwan. And I do these videos for fun. And I'm definitely going to see you in the next video where I'm going to implement some more functionality for this project. Ideally, I want to implement a full-fledged online store which is going to accept Bitcoin. I'm not building this for any clients. I just want to learn how Bitcoin works. I want to learn how to receive Bitcoin, and ideally also how to receive Lightning layer 2 payments. I know I'm kind of late to the party, but I'm just doing this for this 16-year-old myself who was stupid enough not to buy Bitcoin, I guess. So thank you for watching. I hope you learned something, and I will see you in the next video. Goodbye.